Welcome back to math time with Mr. Bywater. Go away, man. I'm sorry, guys. That guy's a little bit crazy. So, yeah, we're going to do a little bit of math today. We're going to start talking about compound interest and a little bit about money. I like money. Money is good. Yeah. Okay, go away. All right, sorry. We'll try to get through this without Igor bothering us again. So we talked a little bit about simple interest before, right? You remember that with simple interest, say I start with 2,000 RMB. Obviously, it doesn't matter unless I can't spell RMB correctly. So we start with 2,000 RMB, and let's say that we have simple interest of 5%. Now, simple interest, remember, is always based off of the initial amount. So if I start with 2,000 RMB, I get 5% of that 2,000 RMB. Well, 10% would be 200, so 5% is 100. So after 1 year, for example, if it's 5% per annum or per year, then I would have a total of 2,100 RMB. Now, the second year, I would get 5% again, but remember the 5% in simple interest is still based off of the original 2,000. And so after 2 years, I'd add on another 1,000, which would now give me 2,200 RMB. Okay, and this ended up being a linear relationship because every year when I add on that 5%, it's always the same amount. It's a common or constant difference, right? And so again, the third year refers back to that 2,000, I add on another 100, and then after 3 years, I've gotten all the way up to 2,300. Okay? Now, what I want to look at now is something called compound interest. Now, most banks nowadays don't go off of simple interest. They go off compound interest. Compound, like Frankenstein made of lots of things. Oh, man, I wish that guy would just stay away. All right, so compound, yes, means that we're building on other things. We're putting pieces together. So when we do compound interest, if we have compound interest, which is, let's say, we'll start again with the same 2,000 RMB, and we'll do the same percentage, 5% per annum. Okay, but this time we're going to compound. Now what that means is the first year we get 5%, and that 5% is dependent on that 2,000. So 5% of 2,000 is 100. So when I add that together, I get the same as before. I still have 2,100 RMB. Now this is where the difference is going to come in, because now I'm going to do 5% for the second year, but in compound interest, it compounds, it adds on, it adds pieces together. And so this time, the 5% is going to be on the 2,100. And if I do 2,100 times 5%, I now get 105. So I go plus 105 this time. And so now I have $2,205, RMB. Okay? And then the third year, when I add in that 5% again, this 5%, you get interest on the interest that you got before. And so this time, it'll be 2,205 times 5%, which this time, I'm going to get to add 110.25. And so we get a total then of 2,315.25. And you look at that and you may say, well, yeah, but that's not a big difference. That's 15 RMB. Well, yeah, over a short term, that's not a big difference. But I think you'll see as we look at this later, as we start to put some of these things together and look at some different types of problems, it actually does turn out to be quite significant when we have multiple compounding and when we have lots of money there to start with. All right? Now, one of the things I want you to recognize is why are we bringing this up now, right? The simple interest we talked about when we were talking about the linear graphs, right? And also the arithmetic sequences, right? Now, this one, why is this coming up now? Well, we just talked about geometric sequences. right? So at this point, we start with the very first year, 2000, right? The second year, we have 2000 plus 2000 times 0.05, right? That's adding on that 5%. Now, if I put those together, that's the same thing as 2000 times 1 plus 0.05. Okay, now you're not going to have to go through this every time, but I want you to see the connection to the geometric sequences. All right, then the next year we'll have that. We'll have the 2000 times 1 plus 0.05, and we're going to add on that 2000 times 1 plus 0.05 times 0.05, right? Because it's going to be 5% of what I had there. Now, again, I should be able to factor this out so that I'm going to have 2000 times 1 plus 0.05 times 1 plus 0.05, right? Because I just took the 2000 plus 1, 2000 times 1 plus 0.05 here, and then I'm also taking the 2000 plus 1 plus 0.05 there. So what I'm left with is 1 here and 0.05 there, okay? Now, of course, what that means is that it is 2000 times 1 plus 0.05 squared. And so looking at these terms, you start with 2000, then you got 2000 times 1 plus 0.05. Now you got 2000 times 1 plus 0.05 squared, right? That is very reminiscent of a geometric sequence. And in fact, it is. Okay, I'm going to present you on the next slide to an equation, a formula that's going to look very, very similar to your geometric formula, your geometric sequence formula, but it's going to be slightly different. The formula on this next page is also in your formula packet, all right? And so you'll be able to use this, and you don't need to be able to do that process that I just did. I just wanted to show you so you could see that connection, that relationship, all right? So let's look at this formula that I've got here at the top of the page. So I want to introduce you to this formula, which is FV, which is the future value, equals the present value times 1 plus R. R is the rate in percent. So for example, in the last question, it was 5%, right? If it's 5% per annum, then R would be 5, okay? The 100 down here on the bottom is going to take care of the percent part, okay? It's down there for you. You can just put the percent straight in. The N is the number of years, all right? So this formula, now I don't want you to accuse me of lying to you. Like, meet the Bible till you lie all the time. No, I do not. I do not lie to my students. All right, so I'm not lying to you. This formula is not in your formula packet exactly, but it's really, really close. And I'll show you in the next video the formula that's actually in the packet and how you can get this, all right? So I want you to recognize that this formula exactly this way is not there, but you'll be able to get it, no problem, all right? So this is a formula that you can use. This, if you think back to the previous slide, you can think of this is the money that we have, this is what we started with, and then this is that 1 plus the percentage to the power of the number of years. And that's what we were seeing in that kind of geometric sequence type situation, all right? So let's look at an example, all right? We've got Aditi and Aneri, who each have $2,000 US. Aditi finds a bank with 3% simple interest per year. Aneri finds a bank with 2.9% compound interest per year. How long until they have $5,000 US? Okay, so yeah, let's find out. Now, I actually didn't write this question very well. I meant how long until they each have $5,000. So let's look at Aditi first. Okay, so Aditi has simple interest, right? So Aditi being simple interest, she's going to start with 2,000. And then she's going to each year add 2,000 times 0.03. And that's going to be multiplied by the number of years that passed. All right. We want that to be equal to 5,000. All right. And so you should then be able to solve that. If you want, go ahead and pause the video just for a second, so you can do that if you want. And hopefully you get n equals 50 years. Okay. Now let's look at Aneri. Aneri found a bank with a little bit less percentage, 2.9%, but it is compound interest. Okay, so we're going to be using that formula from the previous page. The future value equals the present value times 1 plus the rate over 100, all to the n power. And so the future value we want is 5,000. Present value is 2,000. 1 plus, the R is going to be 2.9 over 100. And we're solving for n. So this you should be able to put straight into your calculator and do an n solve, right? And hopefully you work through it. Please do make sure that you can get it and that you don't have any issues with your calculator. You should get n equals, sorry, it's going a little bit crazy there. Igor, is that you? No, sir, that is not me. That guy. 32.05 years. So our answer here, well, after 32 years, Aneri does not yet have 5,000, right? It's a little bit more than 32, but the interest, when we do the compound interest, if it's once per year, the interest only comes at the end of the year. And so the answer for Aneri will actually be n equals 33, because it will actually take that one more year for her to go over 5,000 US dollars. All right. Now, another interesting question would be how long until they have $5,000 combined? Can you think of how you would do that? Pause the video. See if you can write a formula that would allow you to calculate how many years it would take for them to combine to have $5,000. Say that they want to get together and buy a boat or something. I don't know. What do you guys want to buy at ET and Airy? You want to buy a boat? It's not enough for a sports car, sorry. All right, so hopefully you have something like this. Bloop, right there. So you've got the amount that Aditi would have after n years. You've got the amount that Aneri would have after n years, and you add that together to get a total of 5,000. And again, this should be something that you should be able to just put straight into your calculator and do an n solve. Honestly, I don't know the answer. I just made up that question. It seemed like a fun question. And you know what? Sometimes we just answer questions that look like they're fun. We don't need a reason to do it, right? It's just fun. Anyway. There you go. That's the first video. Hopefully that makes sense and gives you a little bit of introduction to compound interest. Try a couple of questions and then go on to the next video. And in that one, we'll talk about where we have compounding more than once a year. Yeah. All right. See y'all later.